Good evening, everyone. Myself, Roger G. Smith, working as assistant professor in the department of CSE. Today, I'm going to deal with the topic CPU scheduling algorithms. So, CPU scheduling. It is other name for job scheduling. So, whatever the process we are going to execute in this, whatever the process we are going to have this in queue or in our monitor, whatever the process. So there may be n number of process. So those process we are going to schedule one by one. There may be 5 process, for example. So those 5 process I need to schedule which process has to be executed first. So this is what the first thing is. So among these 5 process, which process I need to execute first, or else among themselves which process has to be executed. So for this scheduling, I have some criteria. Based on those criteria, I am going to derive this scheduling. First criteria. Number 1. Burst time. What is meant by burst time? Burst time is nothing. It's just bursting. So time for bursting, time for execution. So that is what burst time is. So burst time is nothing, your execution time. Burst time is nothing, your execution time. Second, arrival time. Arrival time. So burst time, next one is arrival time. From the word itself, arrival, the process is getting ready. I have arrived. For that meaning, this is arrival time. So at what time the process is entered. For example, we have a class, we have normal class going on hourly basis. So the next staff is ready for that. Next staff is ready at the door. So the staff has arrived. When the staff who is inside has completed, he or she may leave. After that, that staff has to enter. So when she came, when she arrived, that comes under this arrival time. Number 2. Number 3. Waiting time. What is meant by waiting time? She arrived or he arrived. The staff has arrived. I have been going on taking the class. She arrived at 5th minute. Till 10th minute, I have been taking the class. But she is waiting from 5th minute to 10th minute. How much time she is waiting? 5 minutes again. So that will be a waiting time for each process. Next is turnaround time. This is the important thing here. So turnaround time is nothing. It's a sum of waiting time plus burst time. So it is a sum of waiting time and burst time. So summing of waiting and burst time will give you the turnaround time. So total completion. The turnaround of this business, the turnaround, how much turnaround do you have? That is what the waiting time plus burst time you will be having as turnaround time. So based on these criteria, we are going to do this CPU scheduling algorithms. So CPU scheduling algorithms is typically based on these 4 criteria. Now apart from this, there is also another one criteria called response time. How fast how fast this process is responding, how fast it is finishing. That is what response time, the length. So we'll go for the CPU scheduling algorithms. So first algorithm, FCFS. So first come first served algorithm. For example, I will be deriving a table of snapshot with process, burst time, P1, P2, P3. So this is process P1, P2, P3 with the burst time of 6, 8 and 2. What are they? Burst time for process P1 is 6, burst time for process P2 is 8, burst time for process P3 is 2. Now this burst time will be in milliseconds. Okay, this burst time will be in milliseconds. It can be either in seconds, minutes or hours. It is based. So burst time will be in any one of this measure. Now process P1 takes 6 milliseconds for execution, burst time. Process P2 takes 8 milliseconds for burst time, and process P3. Now for FCFS, we'll go with the Gantt chart. This chart is named after the scientist Gantt. So we are going with first come first served. Here first process is P1, P2 and P3. We'll do it. P1, P2 and P3 starting with the arrival time, starting with the time 0. So what is the burst time for process P1? 6. So 6 milliseconds it is executing. So 6 milliseconds it is executing. Next P2. P2 is 8 milliseconds. So P2 is executing 8 milliseconds. So how much from 0 to here? 6 plus 8, it will be 14. Next P3 for 2 milliseconds, 14 plus 2, 16. So this is what Gantt chart is. So based on this process, first come first served, this is the order. In this order each process is executing for particular time, that is burst time. Now 0 to 6, 6 to 14, 14 to 16 based on the burst time. Now our criteria is, one of the criteria is waiting time. We need to calculate the waiting time. So we will go with the waiting time calculation. So for P1, how much time it is waiting? 0. Next P2 is waiting for 6 milliseconds and P3 for 14 milliseconds. So this is what your waiting time is. When it is arrived and you are going to wait, it is waiting until the next process. So P1 at 0, that means it started its execution at initially at 0 and it finishes its execution, and P2 starting at 6, so 6 seconds is waiting. So waiting time we have calculated. Now average waiting time, 6 plus 14 plus 0, that is 20 divided by 3, probably 6.5 Mm, again 6. Let it be around 7 milliseconds. Now we need to calculate turnaround time. Again, what is the calculation? What is the formula for turnaround time? Is waiting time plus burst time. Let us see. 6 plus 0, 6. 6 plus 8, 14. 14 plus 2, 16. Now again, average turnaround time equal to 16 plus 14 plus 6, 26, 20. 20 plus 16, 36 by 3, which is equal to 12 milliseconds. Now our thing is, which scheduling algorithm has minimum average waiting time, minimum average turnaround time? This is what we need. So first we have calculated for FCFS, that is first come first served. We have calculated average waiting time as well as average turnaround time. Now we'll go for the second method. Second algorithm is shortest job first. So in this shortest job first, we have two types. One is preemptive and another one is non-preemptive. So let us see what is non-preemptive first. We have that table snapshot, process, burst time, P0, P1, P2, and burst time let it be 6, 3 and 5 burst time. Now the name itself suggests shortest job first. So among this burst time, which is shortest, that is what we need to take first. Drawing the Gantt chart, starting at 0, which has the shortest burst time, 3. So P1. Next shortest is P2 and P0. Now what is the execution of P1? 3. Execution time for P2 is 5. 3 plus 5, 8. And execution time of P0 is 6. So 8 plus 6, 14. So 0 to 14. Now again, waiting time. How much time each process is waiting? P0 waits for 8 milliseconds. P1 waits for 0, nothing. P2 waits for 3 milliseconds. Again, turnaround time. Formula for turnaround time: waiting time plus burst time. So 6 plus 8, 14, 3 and 8. So based on this, we are going to calculate average waiting time and average turnaround time. So 8 plus 3, 11 by 3, and average turnaround time will be 11 plus 14, 25 by 3. This will give you the average turnaround time and average waiting time for non-preemptive scheduling. Now again, we'll go for shortest job first as preemptive scheduling. How this preemptive scheduling is? Let us have the same process, burst time, P0, P1, P2, P3 will have 4 process, no issues. N number of process we can add. So P0, burst time let it be 6, 2, 4 and 3, or else we'll have 7 and 1, let it be. So here we are going to add another one time, arrival time 1, 2, 3. For this, now we are going to draw the Gantt chart. Zero. At arrival time 0, what process is entering? P0. At arrival time 0, only one process at 0, 6. And it is executing for 1 second till 1. Next, now at arrival time 1, 2 processes are there. At arrival time 1, at 0 only one process, at arrival time 1 now 2 processes are there. Now already here 1 second it is executed, and now remaining 5 seconds and P1 is entering at arrival time 1. Now compare 5 and 2. Among this, which is shortest? P1. So it is also executing for 1 second. At arrival time 2, P2 is entering. At arrival time 2, P2 is entering. Here now it is 1, here 7 and 5. Among this 5, 1 and 7, which is shortest? Again P1. It is executing for another 1 second. Next, at arrival time 3, this finishes its execution. Now at arrival time 3, P3 is entering with burst time of 1. P3 is entering with the burst time of 1 and P3 finishes its execution. Next, P0 and P2, 2 are remaining. Among this P0 and P2, which has the minimum burst time? P0, which has the burst time of 5, 9, and next P2, 7, 16. So till 16 we have all those things. So if you count the burst time, 1 plus 7, 8 plus 2, 10 plus 6, altogether burst time will be 16. That 16 you must be getting at the end. Now listen, how will you calculate the waiting time for each process? P0, it's executing here, it is executing here. So P0 is executing for 1 second. After that it is waiting till 4th second. So it is waiting for till 4th second from 1. So waiting time will be for P0, it will be 0 to 1, it is executing. So 0 plus 4 minus 1. This many times it is waiting for execution, which is equal to 3 P0. Next, P1 at 1 second plus executing till 3. Any other? No. So nothing. 1. Now you need to check the arrival time. P1 is executing at 1st second, but it has arrived only at 1st only. It is not at from 0 and all. So it is not waiting at all. Arrival time is 1. So at 1 only it comes, finishes its execution, leaves. So it is not waiting anywhere. Next, P2. 9. So till 9 it is waiting from 3. It arrived at 3, till 9 it is waiting, no other P2 is there. So 9 minus 3, it is waiting for 6 milliseconds. So next, P3, sorry, arrived at 2, so it's 7, and P3 3, till 3 it is waiting, finishes its execution for 1 second, it finishes. The thing is, P3 doesn't wait because it came at 3rd second, finishes its execution, went off. So waiting time for P3 is 0. So altogether 7 plus 3, 10 divided by 4 will be your average waiting time. Now turnaround time. Formula, burst time plus waiting time. So 3 plus 0. Next, 0 plus, sorry, 3 plus 6, 9. Next, 0, 0 plus 2, 2. Next, 7 plus 7, 14, and 0 plus 1, 1. This is what turnaround time. So now you might have understood what is preemptive scheduling and what is non-preemptive scheduling. If a process is starting, it is executing. So here, till here, P naught has to wait. So it is waiting. It is interrupted by two processes, P1 and P3. So it is interrupted so that it is waiting for its execution. This is what preemption is. Non-preemption, if P naught starts its execution, it will finish and then only the other process will be starting. So this is what preemptive scheduling of SJF is. Now here remaining time is there na. We are calculating the remaining time. So the other name for SJF preemptive is shortest remaining time first scheduling. Shortest remaining time first scheduling for SJF preemptive. Going for next scheduling algorithm is priority. Now exactly like SJF, you will be having two types, preemptive and non-preemptive. Now coming here, priority, the same, I will be having a process. I will go with the first non-preemptive process, P0, P1, P2, P3. Burst time 3, 2, 6, 4. Along with this burst time, I am adding one more column, priority. Priority is nothing, ranking. I am going to rank 4. How many processes? 1, 2, 3, 4. Whatever it is, 2, 3, 1. So this is the priority or ranking I am going to give for this process. In this order only I am going to execute it. So what is first? P3. Next is P1. Next is P2. And at last P0. Execution time 0. P3 4. P1 2 6. P2 6 12. And P0 3 15. So waiting time for P0 it is 12. P1 it is 4. P2 it is 6 and P3 0. Average waiting time, normal calculation, and turnaround time waiting time plus burst time, we will be having turnaround time, average turnaround time. Now, important point, priority preemptive. How priority preemptive is? Process P0, P1, P2, P3. Burst time 6, 4, 5, 7. If it is preemptive, default you will be getting this arrival time. So 0, 1, 2, 3 and priority 4, 1, 3, 2. Now Gantt chart. P0 at arrival time 0, P0 only one process is there, so P0 it is executing for 1 second. Next P1 arrives at 1. Among these P0 and P1, which has the highest priority? P1 has the highest priority, so P1. So P1 executes for another plus 1, so two. Okay, so 2 seconds, here minus 1, and here 1 second it is taken. Next at arrival time 2, P2 is also entering, but burst time is 4, here 3, here 5. 5, 5, 3. Among this again you will be having ranking priority 4, 1, 3. Don't see the burst time, you are going to see the priority. So which has a higher, lower priority? I mean highest ranking. 1, again P1 will be executing for another 1 second. Again 4 minus 1, 3 minus 1, now it's 2, and here again at arrival time 3, P3 is also entering, burst time is 7, but comparing to P0, P1, P2, P3, P1 has again shortest, highest ranking. It will be executing for another 1 more second. Next, so next you will be having here only 1 second remaining, and priority will be 1, 4, 3, 2. So complete that priority 5. So 1 to 5, that is 4. Altogether priority is completed. And next priority is P3. Next priority is P2, and last P0. So what is the execution time 5? Again P3 has the execution time of 7, 12. P2 has the execution time of 5, 17. P0 balance is 5, 22. Now how will you calculate? The same like SJF preemptive. The same thing you are going to calculate as for this priority preemptive. Now the last, round robin. Here there is no arrival time, no waiting time, no arrival time, no priority. The thing is, you are going to add one thing, time quantum, which is equal to, let it be 2 seconds or 2 milliseconds or 2 hours, whatever, based on that. Now we'll have a snapshot, process, burst time, P0, P1, P2. burst time of 6, 3 and 4. 6, 3 and 4. Now time quantum 2 means, drawing this Gantt chart, each process has to execute only for 2 seconds. Each process has to execute only for 2 milliseconds, seconds, hours, whatever. Now P0 is executing for 2 seconds, minus 2, which is equal to 4. Next, P1 is executing for 2 seconds, minus 2, which is equal to 1. Next, P2 is executing for 2 seconds, minus 2, which is equal to 2. Next, remaining again FCFS. First come P0, remaining 4 is there, 2, which is equal to 2. So it is executing for 2 seconds. We have 2 seconds, but for P1 it is only 1 second is remaining. So P1 it will be 9. P1 finishes its execution. Next, P2 it also finishes its execution, 11. Remaining 2 is there, P0 13. So if you count the burst time, it will be 13, 13. So now you calculate the waiting time for P0. It is 0 plus, from 2 to 6 it is waiting, so 6 minus 2, again plus 8 to 11, 11 minus 8. Next, P1, from 2 it is waiting, plus 4 to 8. Any other P1? No. So that will be the waiting time for P1. Next, P2, 4th second, plus any other P2, 9, 6. So 9 minus 6, no other P2. So this is how you need to calculate the waiting time. So calculating waiting time and average waiting time, calculating turnaround time, average turnaround time. So after finishing all those things, we need to compare which algorithm has minimum waiting time, average waiting time, and minimum turnaround time and minimum average turnaround time. Apart from these 4 algorithms, there are 2 more algorithms, multi-level queue and multi-level feedback queue. Both are based on these 4 algorithms: FCFS, SJF, and priority and round robin. So when you combine any 2, you will be getting multi-level queue, multi-level feedback queue. So this is what about CPU scheduling algorithm is. So thank you all.